I have a Labubu factory. Now, each time I sell a Labubu, I gain $2. And I want to model this relationship using a line on a graph. So, how do you graph lines? What does that really mean? Well, when you're graphing lines, right, you're going to have an x axis, you're going to have an x axis, and you're going to have a y axis. Now, the x axis represents something known as the independent variable, and the y axis represents something known as the dependent variable. All right. So in this case, what is on our x-axis? The thing that is on our x-axis is going to be the amount of Labubus that I sell. Okay. And on the y-axis, I'm going to have the amount of money that I have, right? Because the amount of Labubus that I sell affects how much money I have, right? AKA the amount of dollars that I have, that depends on how much Labubus that I sell, which is why the y-axis, the thing on the y-axis is something called a dependent variable, because the amount of that depends on how much you sell in this case, right? So we can model this using a line. Now, if I sell nothing, right? If I sell 0 Labubus, I'm gonna end up with $0, right? That makes logical sense. So I'm just gonna put a dot right over here. This is something known as the origin. It's basically when both the x value and both the y value is 0, right? If we sell 0 amount, well, we're gonna get $0. So both of the x and the y values are 0 in this case. Now, if I sell 1 Labubu, how much money am I going to get? Well, each Labubu I sell, I get $2. So if I sell 1 Labubu, I get $2. So I am going to graph that one here. I'm going to graph this point, right? If I sell 1, I get $2. Let's do another one. What if I sell 2 Labubus? Well, 2 times 2 gives me 4, right? So I'm going to get $4. Right? If I sell 1 Labubu, I get $2. Well, if I sell 2, I get $4. And you can kind of find out the trend here, right? If I sell 3 Labubus, well, that means that I'm going to get $6. Boom, like that. And if I sell 4, I'm going to get $8, right? So notice how every time you sell a Labubu, you get an extra $2 every time. And essentially what we have right over here is a line. We have a line. So this is going to be our line. I know it's not the most prettiest line, but you can kind of see, right? This right over here is going to be our straight line. I know it doesn't look straight, but you kind of get the idea, right? So whenever we're trying to graph different relationships, we're basically, when we're using a line, when we're trying to graph relationships using a line, we're basically trying to find out how does the x value change affect the y value, all right? So as the x value changes from one term to the next term, well, how does the y value change in response to that? All right. Now, let's say if I wanted to graph y is equal to 3x plus 6. Now, how do we do this? Once again, this is going to be a relationship between variables. On our x-axis, we are going to have the x values. So on our x-axis, we have the x values. And on the y-axis, we're going to have our y values. Now, when our x value is equal to 0, so when our x value is equal to 0, well, what is our y value? Well, if I plug in 0 into x right over here, notice how I get 3 times 0 plus 6. 3 times 0 is just 0. So I'm just going to be left with this positive 6 at the end. So when our x value is equal to 0, our y value is equal to 6. So let me graph that up here. And I'm just going to label this point 0, 6. This just tells us that when the x value is 0, our y value is 6. Now, what happens when our x value is equal to 1? What happens if our x value is equal to 1? Well, if I plug 1 in for x, I get 3 times 1, right? So I get y is equal to 3 times 1 plus 6, right? 3 times 1 is 3. 3 plus 6 is 9. So essentially, when our x value is equal to 1, our y value is equal to 9. Therefore, this point is called 1 comma 9. This point, the location of this point is going to be 1 comma 9. This 1 represents the x value, this 9 represents the y value. And you can just keep on doing this for more and more points. You'll notice how as the x value increases, the y value will always increase by 3. So essentially, when x is equal to 2, if you actually plug 2 into this equation, you actually get 12. Then after that, you'll get 15, 18, and so on. Right? And boom, there we go. This is going to be a straight line. You can also plug in negative numbers into this. So when x is equal to -1, well, if I plug in -1 in for x, I get y is equal to 3 times -1 plus 6. 3 times -1 is -3. -3 plus 6 is +3. So that means that when x is equal to -1, our y value is equal to 3. And notice how even though our x value is negative, it still follows the trend of being a straight line, okay? So boom, there we go. Now, one thing to notice is this 3 right over here. Notice how as I move up 1 unit, notice how my y value increases by 3 every time. Right? Originally, I started at 0,6. After I moved 1 unit to the right, notice how I go 3 units up, right? So let me actually do this in a different color. So look, I originally started at 0,6. Now, if I move 1 unit to the right and I move 3 units up, notice how this gets me to 1 comma 9, which is the next point, right? And if I do the same thing, I move 1 unit to the right and 3 units up, I get to the next point, which is 2 comma 12, right? 2 comma 12. I move 1 unit to the right, I move 3 units up. That gets me to 3 comma 15, and so on, right? So you see how there's like a little bit of like a staircase going on here. But what this 3 represents is basically how much our y value is going up every time our x value goes 1 to the right. So every time my x value goes 1 unit to the right, my y value is going to go 3 units up. 1 unit to the right, 3 units up. 1 unit to the right, 3 units up. If I go 1 unit to the left, can you guess what happens? Well, instead of going 3 units up, now I go 3 units down. This is why this point is located right over here. When I go 1 unit to the left, in this case, I'm going to go 3 units down. In this case, it's going to be the opposite of what I do if I were going to the right. Okay? And in fact, this 3 is something known as the slope. This 3 is something known as the slope of our line. It basically tells us how steep is this line. Lines that have a very big slope, you might expect look something like this. I'm trying to draw the line as straight as I can. But look, the lines that are very steep, it has a very high slope, right? It would look something like this. But lines that are not that steep might look something like this, right? Where the slope of this line, right, is not that steep. All right. So that is essentially what this 3 represents. What does this 6 represent? Well, this 6 essentially represents something known as our y-intercept. Y-intercept. Now, this is just the y value. You can think about this as our starting value, okay? So essentially, when we start at x is equal to 0, right? Let's just say we start at x is equal to 0. Well, when our x value is 0, notice how the y value is 6, right? When the x value is 0, the y value is 6. So 6 essentially represents our starting point, right? When our x value is absolutely nothing, we start out at y is equal to 6. So that is essentially our starting point. So starting point. And based off of these two things alone, you can graph out linear equations. So for example, look at this. Let's say if I have the graph y is equal to 2x plus 1. How do I graph this out? Well, right? Well, this 1 right over here, remember, that represents our starting point, right? This term at the end right over here represents our starting point. So essentially, when the x value is equal to 0, our y value is equal to 1, right? So So when our x value is 0, our y value is equal to 1, right? Notice how when you plug in, you put in 0 in for x, you get out 1 for y, right? And then after you take a look at the starting point, then you're going to take a look at this number in front of the x. This number in front of the x, once again, this is your slope. It tells you how steep the line is. And essentially, it tells you how much you move up, every time you move 1 unit to the right. So look, if I move 1 unit to the right, that means that I'm going to move 2 units up. If I move, this is not that. All right. I move 1 unit to the right, I'm going to move 2 units up. So let me do this. Just erase this real quick. When I move 1 unit to the right, I'm going to move 2 units up. So 2, should put 3 here, 5, make it nice. 7, this is 1, 2, 3, 4. All right. So look, when I move 1 unit to the right, well, what am I going to do? I'm going to move 2 units up. So I'm going to move 2 units up. Notice how I go from 1 to 3, right? Because if I go 2 units upwards, that means that I'm adding, right? I'm going 2 units up. So what's 1 plus 2? That gives me 3, right? And then my next point is going to be here, 1, 3. Let's do this one more time. I move 1 unit to the right, and I'm going to move 2 units up. So then my new point is going to be located at, well, it looks like my new point is going to be located at 2, 5, right? I move 1 unit to the left, so 1 left of 1 is going to be 2. 1 right of 1 is going to be 2. And if I move 2 units up from 3, well, 3 plus 2 gives me 5. So this is going to be my next point. I'm just going to keep doing this staircase, right? 1 unit to the left, 2 units up, 2 units up. So I'm going to reach 7. So this is going to be 3, 7. Okay? This point right over here is going to be when our x value is 3, our y value is going to be 7. And boom, there we go. When we kind of connect all these lines, when we connect all these points together, we should get a straight line like so. And you can do this the opposite way as well. You could say, okay, I can go 1 unit to the left and 2 units down. 1 unit to the left, 2 units down, right? And you would still get the same straight line, right? If you go 1 unit to the left, that's going to be at x is equal to -1, right? Because it's going to be at x is equal to -1. Because 0 subtracted by 1 gives me -1, right? So go 1 unit to the left, I'm going to go 2 units down. So what's 1 minus 2? Well, that's just going to be -1. So this point right over here is going to be -1, -1. All right? And I just keep repeating this pattern. I'm going to go 1 unit to the left, so this is going to be at -2, right? And if I go 2 units downwards, well, what's 2 units downwards from -1? Well, if I go 2 down from -1, that's going to be -3 now, right? Because I'm getting more negative, right, as I move downwards. So this point right over here is going to be -2, -3. All right? And I'm able to graph out this straight line from this, okay? So the important thing to remember is that all lines can be modeled by the equation y is equal to mx plus b. M represents your slope, the slope of the line, right? In this case, for y is equal to 3x plus 6, 3 in this case would be my m value, right? That would be the slope of the line. And the b value is our starting point, or our y-intercept. All right? So it's basically the y value. It's basically what is your y value when your x value is 0, right? When you're just starting out, how high up are you? And there we go. We can use this to graph the lines. Let's say if we're given a graph of a line. So let's say if we're given whatever this graph is right over here, and we want to find out what's the equation of the line in the form of y is equal to mx plus b. So in order to do this, well, what you have to realize is that, well, what is our slope? Remember, the slope of the line is how steep it is, right? So notice how when I move to the right by 1 unit, notice how I move 4 units up. So every time I move 1 to the right, I move 4 units up. That means that my slope is going to be 4, right? Every time x increases, well, the graph increases 4 units by y, right? That's why I have a 4x here, right? And this b represents our y-intercept, our starting point. Well, what is our starting point? well, our starting point, when x is equal to 0, well, notice how the y value is -4. So our graph would be 4x minus 4. All right, and that's going to be our answer. Now, another way you can think about slope. Slope is defined by our change in y divided by our change in x. So the slope of a line is essentially how much does your y value change? So the slope of our line, another way you can think about it is how much has our y value changed every time x value has changed. All right, so when the y value changes, how much does the x value change? You divide those two things together and you get the slope of the line. Well, let's take a look at how to calculate slope using a formula. So this is going to be the formula for calculating slope. All right. Now, notice how one of the points I have is 1, 0. And another point that I have on this graph is 0, -4. Right? When x value is 0, the y value is -4. I can label these points. Okay, so let's just say this is x value 1. Let's just say this is y value 1, right? Because this is the y value of the first point. And let's call this x2, right? Because this is the second x value, and this is the second y value. I'll call this y2. Now, it turns out that if you take the difference in the y values, so let's just say, in this case, y2 minus y1, so what's -4 minus 0, and I divide this by x2 minus x1, aka 0 minus 1, notice how I get -4, because -4 minus 0 is -4, and on my denominator, I get -1. And notice how -4 divided by -1 is equal to +4. Notice how when I use this formula right over here, I get the same result as looking at it visually. Right? Visually, I see that this increases by 4 every time I move to the left by 1. But you can also do this using math. You could say, okay, I know that these 2 points are on the line. I know these 2 points are on the line. So what I can do is I can take the difference in the y values. How much does the y value change every time the x value changes, right? Every time the x value changes. And by dividing both things, by dividing these two things by each other, I actually get the slope of the line, how steep it is. All right. I can do, let's do another problem. All right. So here we go. Let's do another example. So right over here, whenever you're given a line, right, you always, first of all, the first step you want to do is you essentially want to identify 2 points on the line. All right. So first of all, you got to find out 2 points on the line. It could be any 2 points, but to make your life easy, I'll just choose very simple points. So this point right over here is 0, -3. And this point right over here is 2, 1. All right. Now, let's say I want the equation of this line in the form of y is equal to mx plus b. So how can I do this? Well, the first thing I have to do is I have to find the slope of this line. Notice how every time you move 1 unit to the right, you move 2 units up, right? 1 unit to the right, 2 units up. Therefore, the slope of my line, aka the m value, is equal to 2. M is equal to 2. So far we have y is equal to 2x. Now, remember that x and y are variables, so you don't change them, right? When you're writing the equation of line, the x and y, it stays the same, right? Okay, got it? All right, and then now finally, for the b part, right over here, the b represents the y-intercept. So the y-intercept in this case is -3, right? When x is equal to 0, our y value is equal to -3. So we're going to have y is equal to 2x minus 3, and we are done. This is the equation of our line. Any x value, let's just say you input x is equal to 1, x is equal to 2, 3, 4, 5, 6, 7, right? If you input all of these points, right, and you find out what the respective y values are equal to, you're going to end up generating this line. All right. Think about the x value as you put whatever numbers you want into this x value, and then you're going to get some y value out. And when you're done inputting all the x values that you can, you're going to end up with this line right over here. All right. Any x value you put, it's going to output a y value, and anything you put in here, you're going to get a value back, and it's going to become a straight line. Another way you could have done this problem, once again, you could have used the slope formula. y2 minus y1 is equal to x2 minus x1. So in this case, we have 2 points, right? We have 2, 1, and we have 0, 3. So I'm going to label all of these points. So this is going to be the x value for my first point. This is going to be the y value for my first point. This is going to be the x value for my second point, right? And then this is going to be the y value for my second point, right? Once again, sorry, I forgot this negative sign. When we plug this into the formula, we're going to get y2 minus y1, so negative 3 minus 1, divided by 0 minus 2, right? x2 minus x1, 0 minus 2. Right? It's going to be the difference in our y values divided by the difference in my x values. So negative 3 minus 1 is negative 4. This is going to be negative 2. Negative 4 divided by negative 2 is equal to 2. And there we go. That is going to be our answer. Let's say if we want to find out the equation of this line. Okay, first step, always pick 2 points. So I'm going to pick this point, and I'm going to pick this point right over here. This point is negative 1, comma 1, and then the other point is negative 2, comma negative 2. All right. Now, I want to find out the equation of this line, once again, in the form of y is equal to mx plus b. So let's find out our slope first. Remember that our slope, the slope of our line, that's going to be equal to this formula, right? The change in our y values, right? Our y values subtracted, divided by the x values subtracted, right? So in this case, if I label this point x1, this part y1, I label this one the x value of my second point, right? This is the y value of my second point. So I put all of these into my formula. I get negative 2 minus 1, right? y2 minus y1 divided by x2, right? This negative 2 minus negative 1. Negative 2 minus negative 1. Notice how I have two negatives here. Negative negative makes a positive. So I'm just going to get this, which is 2 minus 1, that's negative 3. And then I have negative 2 plus 1. That's going to be negative 1. Negative 3 divided by negative 1 gives me positive 3. So the slope of my line is going to be positive 3. So far I have y is equal to 3x plus b. Now the problem now is that in the previous problems we saw before how we saw the y-intercept, right? Imagine if this line extended all the way up, right? You would easily find a y-intercept here. But the problem is the image is cut off. I can't see the y-intercept. So how am I supposed to find out the y-intercept, if I can't really see it? Well, the trick is that you can solve for the y-intercept if you input one of these points in. Let me show you what I mean. So let's take this point, for example. This point is a point on the line, right? This is negative 1, comma 1, right? We know that when we input a negative 1 in for the x value, I know that I get a 1 for my y value, right? AKA, in other words, I know that when I put in negative 1 in for x, so when I put in negative 1 in for x, I get out a y value of 1, right? I plug in negative 1 here, and I plug in 1 here, right? I know this has to be true because this is a point that's on the line. So, there we go. Now we can solve for b. We can solve for what b is equal to. We get 1 is equal to 3 times negative 1, which is negative 3, plus b. If I add 3 to both sides, I get that b is equal to 4. That means that my equation of the line is y is equal to 3x plus 4. And there we go. That is how you do this problem. So whenever you don't know how to do the y-intercept, just plug in one of the points and you're going to get the value. All right, just plug in one of the points into the x and y values because you know that has to be true, and then you can solve for the y-intercept from there. And it actually does not matter if you plugged in this point or if you plugged in this negative 1, comma 1, or if you plugged in this negative 2, comma negative 2. Everything will still work out just fine, okay?